Mars is the fourth planet from the Sun. Befitting the red planet's bloody color, the Romans named it after their god of war. In truth, the Romans copied the ancient Greeks, who also named the planet after their god of war, Ares. Other civilizations also typically gave the planet names based on its color. For example, the Egyptians named it Erdeshir, meaning the red one, while ancient Chinese astronomers dubbed it the fire star. The bright rust color Mars is known for is due to iron-rich minerals in its regolith, the loose dust and rock covering its surface. The soil of Earth is a kind of regolith too, albeit one loaded with organic content. According to NASA, the iron minerals oxidize, or rust, causing the soil to look red. The cold, thin atmosphere means liquid water likely cannot exist on the Martian surface for any length of time. Features called recurring slope linea may have spurts of briny water flowing on the surface, but this evidence is disputed. Some scientists argue the hydrogen spotted from orbit in this region may instead indicate briny salts. This means that although this desert planet is just half the diameter of Earth, it has the same amount of dry land. The red planet is home to both the highest mountain and the deepest longest valley in the solar system. Olympus Mons is roughly 17 miles, 27 kilometers, high, about 3 times as tall as Mount Everest, while the Valles Marineris system of valleys, named after the Mariner 9 probe that discovered it in 1971, reaches as deep as 6 miles, 10 kilometers, and runs east-west for roughly 2,500 miles, 4,000 kilometers, about 1/5 of the distance around Mars and close to the width of Australia. Scientists think the Valles Marineris formed mostly by rifting of the crust as it got stretched. Individual canyons within the system are as much as 60 miles, 100 kilometers, wide. The canyons merge in the central part of the Valles Marineris, in a region as much as 370 miles, 600 kilometers, wide. Large channels emerging from the ends of some canyons and layered sediments within suggest the canyons might once have been filled with liquid water. Mars also has the largest volcanoes in the solar system, Olympus Mons being one of them. The massive volcano, which is about 370 miles, 600 kilometers, in diameter, is wide enough to cover the state of New Mexico. Olympus Mons is a shield volcano, with slopes that rise gradually like those of Hawaiian volcanoes, and was created by eruptions of lavas that flowed for long distances before solidifying. Mars also has many other kinds of volcanic landforms, from small, steep-sided cones to enormous plains coated in hardened lava. Some minor eruptions might still occur on the planet. Channels, valleys and gullies are found all over Mars and suggest that liquid water might have flowed across the planet's surface in recent times. Some channels can be 60 miles, 100 kilometers, wide and 1,200 miles, 2,000 kilometers, long. Water may still lie in cracks and pores in underground rock. A study by scientists in 2018 suggested that salty water below the Martian surface could hold a considerable amount of oxygen, which would support microbial life. However, the amount of oxygen depends on temperature and pressure. Temperature changes on Mars from time to time as the tilt of its rotation axis shifts. Many regions of Mars are flat, low-lying plains. The lowest of the northern plains are among the flattest, smoothest places in the solar system, potentially created by water that once flowed across the Martian surface. The northern hemisphere mostly lies at a lower elevation than the southern hemisphere, suggesting the crust may be thinner in the north than in the south. This difference between the north and south might be due to a very large impact shortly after the birth of Mars. The number of craters on Mars varies dramatically from place to place, depending on how old the surface is. Much of the surface of the southern hemisphere is extremely old, and so has many craters, including the planet's largest, 1,400-mile-wide, 2,300 kilometers, Hellas Planitia, while that of northern hemisphere is younger and so has fewer craters. Some volcanoes also have a few craters, which suggests they erupted recently, with the resulting lava covering up any old craters. Some craters have unusual-looking deposits of debris around them resembling solidified mudflows, potentially indicating that the impactor hit underground water or ice. In 2018, the European Space Agency's Mars Express spacecraft detected What could be a slurry of water and grains underneath icy Planum Austral? Some reports describe it as a lake, but it's unclear how much regolith is inside the water. This body of water is said to be about 12.4 miles, 20 kilometers, across. Its underground location is reminiscent of similar underground lakes in Antarctica, which have been found to host microbes. Late in the year, Mars Express also spied a huge, icy zone in the red planet's Korolev crater. Vast deposits of what appear to be finely layered stacks of water ice and dust extend from the poles to latitudes of about 80 degrees in both hemispheres. These were probably deposited by the atmosphere over long spans of time. On top of much of these layered deposits in both hemispheres are caps of water ice that remain frozen year-round. Additional seasonal caps of frost appear in the wintertime. These are made of solid carbon dioxide, also known as dry ice, which has condensed from carbon dioxide gas in the atmosphere. In the deepest part of the winter, this frost can extend from the poles to latitudes as low as 45 degrees, or halfway to the equator. The dry ice layer appears to have a fluffy texture, like freshly fallen snow, according to a report in the Journal of Geophysical Research Planets. Mars is much colder than Earth, in large part due to its greater distance from the Sun. The average temperature is about -80 degrees Fahrenheit, -60 degrees Celsius, although it can vary from -195 F, -125 C, near the poles during the winter to as much as 70 F, 20 C, at midday near the equator. The carbon dioxide-rich atmosphere of Mars is also about 100 times less dense than Earth's on average, but it is nevertheless thick enough to support weather, clouds and winds. The density of the atmosphere varies seasonally, as winter forces carbon dioxide to freeze out of the Martian air. In the ancient past, the atmosphere was likely thicker and able to support water flowing on its surface. Over time, lighter molecules in the Martian atmosphere escaped under pressure from the solar wind, which affected the atmosphere because Mars does not have a global magnetic field. This process is being studied today by NASA's MAVEN, Mars Atmosphere and Volatile Evolution mission. NASA's Mars Reconnaissance Orbiter found the first definitive detections of carbon dioxide snow clouds, making Mars the only body in the solar system known to host such unusual winter weather. The red planet also causes water ice snow to fall from the clouds. The dust storms on Mars are the largest in the solar system, capable of blanketing the entire red planet and lasting for months. One theory as to why dust storms can grow so big on Mars is because the airborne dust particles absorb sunlight, warming the Martian atmosphere in their vicinity. Warm pockets of air then flow toward colder regions, generating haze. Strong winds lift more dust off the ground, which, in turn, heats the atmosphere, raising more wind and kicking up more dust. The axis of Mars, like Earth's, is tilted with relation to the Sun. This means that, like Earth, the amount of sunlight falling on certain parts of the red planet can vary widely during the year, giving Mars seasons. However, the seasons that Mars experiences are more extreme than Earth's because the red planet's elliptical, oval-shaped orbit around the Sun is more elongated than that of any of the other major planets. When Mars is closest to the Sun, its southern hemisphere is tilted toward the Sun, giving it a short, very hot summer, while the northern hemisphere experiences a short, cold winter. When Mars is farthest from the Sun, the northern hemisphere is tilted toward the Sun, giving it a long, mild summer, while the southern hemisphere experiences a long, cold winter. The tilt of the red planet's axis swings wildly over time because it's not stabilized by a large moon, such as Earth is. This led to different climates on the Martian surface throughout its history. A 2017 study suggests that the changing tilt also influenced the release of methane into Mars' atmosphere, causing temporary warming periods that allowed water to flow. According to NASA, the atmosphere of Mars is 95.32% carbon dioxide, 2.7% nitrogen, 1.6% argon, 0.13% oxygen, 0.08% carbon monoxide, with minor amounts of water, nitrogen oxide, neon, hydrogen deuterium oxygen, krypton, and xenon. Mars currently has no global magnetic field, but there are regions of its crust that can be at least 10 times more strongly magnetized than anything measured on Earth, which suggests those regions are remnants of an ancient global magnetic field. Mars likely has a solid core composed of iron, nickel and sulfur. The mantle of Mars is probably similar to Earth's, in that it is composed mostly of peridotite, which is made up primarily of silicon, oxygen, iron, and magnesium. The crust is probably largely made of the volcanic rock basalt, which is also common in the crusts of the Earth and the Moon, although some crustal rocks, especially in the northern hemisphere, may be a form of andesite, a volcanic rock that contains more silica than basalt does. Scientists think that on average, the Martian core is between 1,800 and 2,400 miles in diameter, 3,000 and 4,000 kilometers. Its mantle is about 900 to 1,200 miles, 5,400 to 7,200 kilometers wide, and its crust is about 30 miles, 50 kilometers, thick. The two moons of Mars, Phobos and Deimos, were discovered by American astronomer Asaph Hall over the course of a week in 1877. Hall had almost given up his search for a moon of Mars, but his wife, Angelina, urged him on. He discovered Deimos the next night, and Phobos 6 days after that. He named the moons after the sons of the Greek war god Ares. Phobos means fear, while Deimos means rout. Both Phobos and Deimos are apparently made of carbon-rich rock mixed with ice and are covered in dust and loose rocks. They are tiny next to Earth's moon and are irregularly shaped since they lack enough gravity to pull themselves into a more circular form. The widest Phobos gets is about 17 miles, 27 kilometers, and the widest Deimos gets is roughly 9 miles, 15 kilometers. Both moons are pockmarked with craters from meteor impacts. The surface of Phobos also possesses an intricate pattern of grooves, which may be cracks, that formed after the impact created the moon's largest crater, a hole about 6 miles, 10 kilometers, wide, or nearly half the width of Phobos. They always show the same face to Mars, just as our moon does to Earth. It remains uncertain how Phobos and Deimos were born. They may have been asteroids captured by Mars' gravitational pull, or they may have been formed in orbit around Mars the same time the planet came into existence. Ultraviolet light reflected from Phobos provides strong evidence that the moon is a captured asteroid according to astronomers at the University of Padova, Italy. Phobos is gradually spiraling toward Mars, drawing about 6 feet, 1.8 meters, closer to the red planet each century. Within 50 million years, Phobos will either smash into Mars or break up and form a ring of debris around the planet. The first person to watch Mars with a telescope was Galileo Galilei. In the century following, astronomers discovered the planet's polar ice caps. In the 19th and 20th centuries, researchers believed they saw a network of long straight canals on Mars that hinted at possible civilization, although later these proved to be mistaken interpretations of dark regions they saw. A number of Martian rocks have fallen to the surface of Earth over the eons, providing scientists a rare opportunity to study Martian rocks without having to leave our planet. One of the most controversial finds was Alan Hill's 84001, AL 84001, a Martian meteorite that in 1996 was said to contain shapes reminiscent of small fossils. The find garnered a lot of media attention at the time, but subsequent studies dismissed the idea. The debate was still ongoing in 2016, the 20th anniversary of the announcement. In 2018, a separate meteorite study found that organic molecules, the building blocks of life, although not necessarily life itself, could have formed on Mars through battery-like chemical reactions. Robotic spacecraft began observing Mars in the 1960s, with the United States launching Mariner 4 in 1964 and Mariners 6 and 7 in 1969. The missions revealed Mars to be a barren world, without any signs of the life or civilizations people had imagined there. In 1971, Mariner 9 orbited Mars, mapping about 80% of the planet and discovering its volcanoes and canyons. The Soviet Union also launched numerous spacecraft in the 1960s and early 1970s, but most of those missions failed. Mars 2, 1971, and Mars 3, 1971, operated successfully, but were unable to map the surface due to dust storms. NASA's Viking 1 lander touched down on the surface of Mars in 1976, the first successful landing on the red planet. The lander took the first close-up pictures of the Martian surface, but found no strong evidence for life. The next two craft to successfully reach Mars were the Mars Pathfinder, a lander, and Mars Global Surveyor, an orbiter, both launched in 1996. A small robot on board Pathfinder named Sojourner, the first wheeled rover to explore the surface of another planet, ventured over the planet's surface analyzing rocks. In 2001, the NASA launched the Mars Odyssey probe, which discovered vast amounts of water ice beneath the Martian surface, mostly in the upper 3 feet, 1 meter. It remains uncertain whether more water lies underneath, since the probe cannot see water any deeper. In 2003, Mars passed closer to Earth than any time in that past 60,000 years. That same year, NASA launched 2 rovers, nicknamed Spirit and Opportunity, which explored different regions of the Martian surface. Both rovers found signs that water once flowed on the planet's surface. In 2008, NASA sent another mission, Phoenix, to land in the northern plains of Mars and search for water, which it succeeded in doing. In 2011, NASA's Mars Science Laboratory mission sent the Mars Curiosity rover to investigate Martian rocks and determine the geologic processes that created them. Among the mission's findings was the first meteorite on the surface of the red planet. The rover has found complex organic molecules on the surface, as well as seasonal fluctuations in methane concentrations in the atmosphere. NASA has 2 other orbiters working around the planet, Mars Reconnaissance Orbiter and MAVEN, Mars Atmosphere and Volatile Evolution. The European Space Agency, ESA, also has 2 spacecraft orbiting the planet, Mars Express and the Trace Gas Orbiter. In September 2014, India's Mars Orbiter mission also reached the red planet, making it the 4th nation to successfully enter orbit around Mars. In November 2018, NASA sent a stationary lander called Mars InSight to the surface. InSight will examine the planet's geologic activity by burrowing a probe underground. NASA plans to launch a successor rover mission to Curiosity, called Mars 2020. This mission will search for ancient signs of life and, depending on how promising its samples were, it may cache the results in safe spots on the red planet for a future rover to pick up. ESA is working on its own ExoMars rover that should also launch in 2020 and will include a trip to go deep into the red planet, collecting soil samples from about 2 meters, 6.5 feet, deep. Robots aren't the only ones getting a ticket to Mars. A workshop group of scientists from government agencies, academia and industry have determined that a NASA-led manned mission to Mars should be possible by the 2030s. However, in late 2017, the Trump administration directed NASA to send people back to the moon before going to Mars. NASA is now more focused on a concept called the Lunar Orbital Platform Gateway that would be a moon-based space station and headquarters for further space exploration. Robotic missions to the red planet have seen much success in the past few decades, but it remains a considerable challenge to get people to Mars. With current rocket technology, it would take several months for people to travel to Mars, and that means they would live for several months in microgravity, which has devastating effects on the human body. Performing activities in the moderate gravity on Mars could prove extremely difficult after many months in microgravity. Research on the effects of microgravity continues on the International Space Station. NASA isn't the only one with Martian astronaut hopefuls. Elon Musk, the founder of SpaceX, has outlined multiple concepts to bring people to Mars. In November 2018, Musk rebranded SpaceX's future Big Falcon rocket to Starship. Other nations, including China and Russia, have also announced their goals for sending humans to Mars. If you like our video and content, please like, subscribe and share. Thanks for watching it.